Okay, we'll take a look at the conjugate pairs theorem. What the conjugate pairs theorem says is that if you have a complex root of the form a plus bi, and it is a root of a polynomial, is 0 of f, then the complex conjugate, which is a minus bi, so a minus bi, is also a 0 or a root of f. So therefore all complex roots comes in pairs, where one is a conjugate of the other, where you just change the sign of the complex part. So given that information, we're going to create a function with degree 4, so there has to be 4 zeros. And in this case, we only have 3 showing, 0, 2, and 2 plus I. But according to the conjugate pairs theorem, the conjugate is also a root, which is 2 minus I. So now we have 4 roots. So just like any polynomial, given the roots, we can form the polynomial. So it would be f of x, and then it's always x minus the root. So this would be x minus 0, x minus 2, x minus this whole root, so x minus parentheses 2 plus I, x minus this whole root, 2 minus I. So no one ever writes x minus 0, x minus 2. I can distribute this negative here, so I get x minus 2 minus I, and x minus 2 plus I. So I'm going to multiply these two right here. And then I'm going to multiply these two right here. It's always a good idea to multiply the complex conjugates, because the convenient thing about them is when you multiply them, the complex part or the I part goes away. So you're just left with real coefficients. So you always want to multiply the two conjugate pair factors, and then the rest of them you want to multiply those, and then when you're done with that, you multiply the result. So let me multiply these two out, and I'll just pause the computer real quick. So I first distributed the x over this trinomial. I got this black part here, and then distributed the negative 2 over the trinomial. I got the blue part. Then I distributed the negative I over this trinomial, and I got this part here. That's a sad looking I. So now you want to combine like terms. I like using black. So therefore, this is still x squared minus 2x. And combine like terms, there's no other x squared. Negative 4x. This ix cancels out with that ix. If the ix's don't cancel out, you did something wrong. This 2i and negative 2i cancel out with each other. So I'm left with plus 4 minus I squared, where I squared is equal to negative 1, because I is equal to the square root of negative 1. If I square both sides, I get I squared equals negative 1. So now I have f of x equals x squared minus 2x, x squared minus 4x plus 4, and this is minus a negative 1. So that gives me f of x is equal to x squared minus 2x. And then this is 4 plus 1, which is 5, so that gives me x squared minus 4x plus 5. Okay, so I gave myself a little bit more room down here, and I took this function, just rewrote it down here. So now I'm going to distribute this x squared over this trinomial. So x squared times that, times that, times that. And then I distribute this negative 2 over the trinomial like that, and I line up like terms. And I collect like terms. I get f of x equals x to the 4th minus 6x cubed plus 13x squared minus 10x. And that's correct. Okay, so here we go to 4th degree again. We have a 0 at 1 with a multiplicity of 2, and 1 plus I with a multiplicity of 2. So this would be written f of x would be x minus 1 squared. And this would be x minus 1 plus I squared. My mistake, that multiplicity 2 should not be there. So therefore we don't need that square right there. I don't know how that happened. So therefore, since 1 plus I is a root, we know 1 minus I is also a root. So therefore, x minus the root, 1 minus I. So notice I put it in parentheses. So now I'm going to distribute this negative, and I'll also square this binomial. So I squared this and I distributed the two negatives here. Now I'm just going to multiply the two conjugate pairs, because then the complex part will go away. So let's line that up. So that would be x times these three terms, and then -1 times these three terms. Then this is -I times these three terms. So I just bring out this initial trinomial, x squared minus 2x plus 1. I combine like terms. I get x squared minus 2x. The ix's cancel. The i's cancel. I have plus 1 minus I squared. Again, I squared is equal to -1. So this is equal to x squared minus 2x plus 1. So I squared is -1. I just changed that there. So now this is going to be 1 plus 1. So that's going to be 2. And now I just need to multiply these two trinomials together. So let's start that off. So you multiply x squared times each one of these three terms. And then -2. Multiply that by each one of those terms. And finally multiply 1 by these three terms. So that's x squared minus 2x plus 2. So I now want to collect like terms. X to the fourth minus 4x cubed plus 7x squared minus 6x plus 2. And that's the correct answer. One more example. Okay, for our last example here, we have a root of 2 minus I and a multiplicity of 2. There's that multiplicity of 2 got caught up in the previous problem. So if 2 minus I is a root and it has a multiplicity of 2, that means 2 minus I is also a root, but each one of these conjugate pairs are also a root. So 2 plus I and 2 plus I also must be roots. So now we have 4 roots where all of them are complex. So if we write out the function, we do x minus 2 minus I squared, because there's 2 of them, x minus 2 plus I squared, because there's 2 of those, and each one of them has a multiplicity of 2. So I'm going to rewrite it without this. Assume I distribute the negative. And then since both of these are squared, I'm just going to write it as x minus 2 plus I, x minus 2 minus I, and then the same thing again. X minus 2 plus I, x minus 2 minus I. So therefore there are 2 of these and 2 of those. So now multiplying these two together is the same thing as multiplying those two together. So whatever this result is going to be the same as that one there. And notice that I matched up the conjugate pairs so that the complex number goes away. So I'll just only have real coefficients. So I'm just going to multiply these two first. So I'll multiply x by all the way through on these three terms. Then I'm going to multiply the -2 by these three terms. And multiply I by these three terms. So now I collect like terms. I get x squared minus 4x. The ix's cancel, the 2 i's cancel. I have plus 4 minus I squared. And whatever this result is, I squared it because this is going to be the same thing. So I squared is -1. We've already seen that a few times. So this becomes x squared plus 5. Excuse me, x squared minus 4x plus 5. And now I square that. So in order to square that, I just rewrite it as x squared minus 4 plus 5, x squared minus 4x plus 5 times x squared minus 4x plus 5. And I continue with my multiplication. So I'm going to multiply x squared times these three terms here. So there's my result there. Now I do -4x times these three terms here. There's my result of multiplying -4x by those three. So now 5 times these three terms. And collecting like terms, I get x to the fourth minus 16x cubed plus 26x squared minus 40x plus 25. Okay, so there's conjugate pairs and finding the polynomial given the roots and complex roots.